All right. Hello, everybody. I am Prasanna Kumar Kalever. How are you doing? Good? Yeah. So I'm here to introduce Gluster, and we have done some improvements in Gluster for virtualization use case. And here we go. So I'm going to give a basic introduction of Gluster. My colleague Ramesh have introduced almost most of the parts, but I'm going to recap for some of you who have came to the room newly. So I'll introduce to hyperconvergence and why libjf API is performs better on Fuse, and the Gluster Qemu libjf API integration that gives the high availability of servers, and Unix domain sockets for I/O that we brought recently, some of the sharding features that gave and boost the performance, and finally the dynamic authentication. I have few demos over here, so I'm going to go a little faster. Please interrupt me if you feel anything is missing. Okay, this is Gluster FS. So the basic building blocks of Gluster is blocks. It's not So we'll be having few nodes. They say each of the node will have blocks in it. We combine all these nodes to form a volume, and volume can be of replicate, distribute, and previously it was striped, and now we are not encouraging that. Gluster can be accessed with Fuse, libjf API, that's all about introduction about Gluster. And this is hyperconvergence. Hyperconvergence is a box that has a compute, storage, network, and the virtualization pieces all put together is hyperconvergence. We have some management on top of it. We can with which we can manage the box. Okay. libjf API and the Fuse. Fuse, so here is a Qemu, my application, which talks to the kernel Fuse layer, and from there the Fuse layer will talk to the will send some information to the Fuse, dev Fuse, and from dev Fuse it's talk to the Fuse library, and from there, from the client side, it goes to the brick side, and from the brick side it will finally reach to the file system, that is XFS or whatever. And libjf API, it's an API that applications can directly use, like say Qemu. Qemu can directly use it to communicate with the direct blocks. So we have seen the performance numbers of libjf API is almost 60% performs better than the Fuse. Here is a graph and numbers. Okay. Now I'll tell you the multi-vol file server that we have recently solved. Now overt is a manager on top of everything. It's a GUI kind of thing. It will send some information. So using that we can have some information, and like which volume to select, what kind of volume to select, and how many bricks, what nodes and all. That information can be passed to the VDSM. VDSM will convert it to an XML file, and that will be given to the libvirt. Libvirt converts this XML file that it has got from VDSM, and it gives to the Qemu as a command line arguments. And these command line arguments are taken like multiple vol files or whatever, the volume information and all will be given to will be used by the Qemu to access the Gluster. Okay, so multi-vol file server. So if I have a Qemu command argument, say like this, and I have a URI syntax over there with an IP of 1070 some IP, so I have an undernode Gluster pool, from which I am just using this IP, picking this IP, and I am trying to load my application, load the VM, say. So if this node goes down, what's up? No, even we are having nodes of 100 nodes, and what's the point in having 100 nodes over there? So the solution for this, we need to give. There need to be like too many of IPs or the nodes information here that we pass to the Qemu, so that if one node goes down, it can access the other node. So we have started fixing it from the libjf API side, as I told you. So from the Gluster side, I am coming from this side of it, GlusterFS with libjf API, and we have fixed how to initialize the multiple servers in it, and then we have come with the Qemu. So in the Qemu we pass some arguments. I'm going to show a small demo of how to create a trusted pool and create a replica 3 volume, and then Qemu setup with GlusterFS and libvirt setup over here. Okay. So I am taking 3 nodes Gluster node, 3 Gluster nodes, and I am trying to create a trusted pool out of it. So IP1, IP2, 3. There we go. It's a Gluster pool, and now I am trying to create a Gluster volume, name sample with replica 3 configuration. I'm going to start the volume. Mount it. It's mounted.
So the fourth node is just the client in this case, right?
Sorry.
3 nodes with bricks and 1 is just mounting?
Yes, yes. Okay, this previously what we have done is we have set up a Gluster pool with the replica 3 setup. Now I am trying to configure the Qemu. So here are the patches that send for the Qemu for availability of multiple servers. You can find them easily. I'm configuring it for the x86, enabling with GlusterFS and some debug options. And in the libvirt side, so that is all about configuring the Qemu. And the libvirt side, we have a few patches. I'm going to tell what they are doing. Before that, let us configure the libvirt. With GlusterFS storage driver, and we install it. Now I'm going to show you a small demo how it's going to be useful to have multiple wall servers. Able to see it? Basically, I have recorded with high resolution. Sorry for that. So basically, what I am trying to do here is I'm trying to invoke it with the URL syntax, and since the server is available here, it's trying to boot properly. Yeah, it has booted successfully. Yep. Here I'm trying to kill one of the node in the Gluster volume. So if it was URI syntax that we have used it previously, the same command. So here this node is disconnected now. I am executing the same command here, and I get a transport endpoint not connected. So even though we have a big replica 3 setup, and it's unable to find a server over there. Now this is a new JSON syntax introduced in Qemu. The patches are not yet merged. It has all the information about, the next slide shows you the detailed information about all the options that it was using here. And yeah, the first IP got, it was not connected, so it got a transport endpoint not connected, and it goes to the second node address, and then it boots. Okay, what you have seen is we observed the old URI syntax and its demerits, and then we went for a new JSON syntax. Okay. Okay. Here is the JSON. Actually, the libvirt converts the URI, the XML information that will be given by the VDSM to this kind of commands. And here we see, previously we have seen the JSON syntax that is given as an input for the Qemu, and we have all the information about where is your image, and how many servers we are using in the node, and you can put as many servers as you want, and you can use what transport type you are going to use there, and you can use image path and volume name and all. Now in the libvirt, the recent patches that you have seen, libvirt has the patches for the formatter that exactly formats the information. Okay, this information. Yeah, yep.
So for my understanding, let's say, is there any advantage with respect to the resiliency or the connection over, let's say, connecting to a cluster with a name instead of an IP address, and then have some failover with virtual IPs behind it? Is this more direct, or?
It's like you have a Gluster volume with so and so name, and you have an address to it. I mean, it's an IP or address, doesn't matter. So what you have is the better availability of the servers. Does that answer your question?
Yeah. We can talk later.
Yeah.
Yeah, I got the point. If you just have a kind of load balancer or DNS to say, I have 3 nodes for metadata, and I just check that before the machine. And because when the machine is started and the node goes down, libvirt API will just switch the virtual machine to the correct server anyway, right? So it's just when you want to start the virtual machine that IP has to be available.
So I will answer your question in the next slide.
Okay.
So you got a formatter and a parser. It's not the demo will answer your questions maybe. So yeah, in libvirt side we have a parser and a formatter that parses and formats this kind of information when it is like more like when we take snapshots and all. Backend file information will be stored. Yeah. So yeah, from VDSM side, yeah, this kind of XML will be generated, and you have the more number of available servers over here. Okay, I am going to show a demo which demonstrates using libvirt verse to start a VM and domain XML understanding, and when we create a snapshot, how it backstores all the information. Sorry. Sorry for the interruption. You have slow network. Yeah. So previously we have configured the libvirt, the same one. I'm trying to show it here. So the one which is installed in the local machine with the patches. So we have absolutely no VMs running. I'm going to use this XML with all the backend wall file servers here with the transport and the volume information. Okay, let's start the VM. Let's define this XML and start the VM. Okay, so I'm typing the XML which got actually loaded. So here are the same server information. So the Gluster server information. So we are using the Gluster libgf API way. So image, and with the this is a node information with IP, and you can also have the transport type. It may be an RDMA, Unix, or TCP. So I put into the TCP side all of them. So okay, now I am trying to create an backing file. So this is my image. So this is the original image. Here I am trying to create this image named new snap QCurve2 with the JSON way. So if one of these servers goes down, so initially we have cancelled this. We have killed the cluster D here. So it tries to take from here, and it will create a backing file. Okay, there we are. We have this new file created. Okay, so this image this is an image with the backing file. This is the backing file used here, the Fedora 23 QCurve2, and with that the new snap was created. Here is the same information of Fedora 23s. Yeah.
So I'm going to the question. So other commands like Qemu init check, for example, work with the multiple annotations?
Sorry, can you repeat the question louder?
All the commands, the usual commands for Qemu image, such as, for example, Qemu image check, they check on all of the nodes or whichever node is available?
Yeah, it goes and checks in whichever node it's available. It's try to go for the first server which is available, and if that fails, and it goes to the next and goes on until unless.
And my second question is, this information via libvirt is dynamic. So, for example, one break or node may go down, another may go up, and
If that we need to do from the overt side.
Yes.
Overt side. Actually this information was created from the XML. If the XML has that information, the patches are able to create the JSON syntax, and it will have as number of addresses of all the nodes, and it will try to load from there. Yes.
Just looking at you saw the startup with the multiple IP address trees. It's a patch upstream for libvirt and Qemu. Isn't that more easy just to patch libgf API itself, so that is aware, like you just want to multiple IP address and libgf API try all of them.
Yeah.
And then it's transparent for Qemu on libgf API, or libvirt don't have to or that.
Actually, Qemu initializes the libgf API, the GLFS init, with all the servers that you have given here. So if you don't provide the information for the Qemu, if you don't input the information for the Qemu, the libgf API will not be initialized with those addresses of the nodes.
What I mean is that, for example, you just provide a host name, and the host name has, let's say, four IP addresses. libgf API will try each of those.
Yes.
And then it will be transparent. You don't have to do anything like that, right?
I'm not getting your point actually.
The question is somehow, is it the right place to teach libvirt and Qemu and so on about all these addresses, or should that be transparent? And can the multiple address handling, can't that be inside libvirt API so that all consumers can profit?
Basically, so from my observation, libgf API don't have that intelligence to get all the server's information. So we need to provide it with all the volumes externally, maybe with the Qemu command, and then it gets initialized with those IPs. Okay, so I'm going to create a snapshot with these three IPs as information for that external, for taking the external snapshot. So here is my snap XML that I am going to use when I am trying to create an XML, trying to create a snapshot. This is how I create a snapshot. I use the XML file that I have shown you before. And there we go, we have a snapshot there. And this snapshot information, all the backend chain information will be loaded into the XML. And if you dump the XML, here we have all the information. So this is our new image, and the backend store for that image is our old Fedora 23. So we have all the information about the servers for each given. That's all. So we have seen how to create or start a VM using Versh, and we understand some parts of domain XML, how the Gluster information is put into it, and we created a snapshot with backend store VM image. So what are the improvements that we found is we have done is so since we have used libgf API and it's parse through number of servers and connect to the first available, so through libgf API we have a less context switches and less copying of information from user space to kernel and then to the dev fuse and then going that to the brick. And now we have a better availability. Yeah. So I'm going to cover the third point next. So we have introduced the Unix domain sockets. So it goes like this. So this is the client side of Gluster FS, and there we have the Gluster D running. It's a brick process. Gluster D is a management process, and here we have a Gluster FSD, which is a brick process. Now all the volume related information will be sent from, will be shared, will be taken care by the Gluster D. Generally, the Gluster D and Gluster FSD will be in the same machine. So in all the nodes, Gluster D will be running, and in the nodes which have the bricks, Gluster FSD will run. So then a management information that will be happening frequently will be through like Gluster D and Gluster FS communication, this bridge, that is a management. And the brick process, all the data, like if you have a mount here, if you write something to here, so all the data will be sent through this communication bridge to the Gluster FSD. Now, in case of hyperconvergence, now everything is in the same box. The client and the brick is on the same point. That means basically your VM image, and from where you want to run the Qemu, the application will be residing on the same side. So instead of having generally the TCP connection between these two, where the real data will get transferred, it's better to have a Unix domain sockets which will boost our performance. And here we have seen the performance on an average of 13% with this change. You can see more information over here. Like the write performance at 128 bytes, which is a normal case. If you see this, we have an almost of 13% of improvement in the write. You have improvements in other areas like read, reread, and all. Let's see some demo which shows the Unix domain sockets in action. So we'll try to start a volume here. We mount the volume in a node where the brick is in local, and we observe the UDS in action. So we have a Gluster pool of 2 nodes. So there are no volumes in a cluster. Trying to create a volume named UDS with the 2 nodes. Starting the volume. So we see the volume information. So the second side, I mean the node 2, the one which was doing I was doing previously is a node 1, and this is a node 2, where I see the same information. And switching to the node 1 and see the Gluster FSD running here. It's running here because I'm using the 2 bricks, one from each. So this is okay. So this node, the 1.86 has a brick B1. You can see that information here, and this has a brick 2. I'm just checking the Unix domain sockets connections now continuously. In the same node, I'm trying to mount the volume so that the brick 2 will be local to it, and there we go, we got it connected. That's what we have seen is we mounted a volume in a node where the brick is local and observed UDS. Okay. Now the third part is improvements done with the Unix domain sockets. That's not all. We are also trying to use the same Unix domain sockets, like for the DHT. If the brick is, it has some heuristics that it can find, it can automatically find that the brick is local, and it's going to do that. It's going to switch with UDS. And here is a sharding. Sharding is like consider we have a file of 84 MB. And it will get splitted into each, like whatever configure block size that we have given. Now this 16 MB is a basic block size. I'm going to show a demo of it. So now 84 MB is splitted into 16 MB files. Now 16 plus 16 plus 16 plus 16 plus 4. And this file is a main file, and still it will be 16 MB, and that's what you can see it from the mount point. And the other files will be in the .shard, which are which will be hidden files with a GFID and its index. So we have the index like starts from 8 with the GFID. GFID is a unique for every file, and we have index 1, 2, 3, 4, 5, and since this is 4 MB, and we have that. So sharding splits the file, and this splitted file. Each file will be acted normally for the DHT, and it tries to split the files everywhere, and so that we can use the bricks in an efficient way, all the bricks. So we have a lot of problems that get solved. I'm going to explain you next. So this is a demo of it. So I'm going to create a volume with only one brick. So we need to by default this feature is off, so we need to turn it on. And by default the shard size is 4 MB, and I'm setting it to 16 MB. Trying to mount it. Sorry, I have not started the volume yet. So from the brick side, we have this, and from the mount side, we don't see. I'm trying to create a file here. From the mount side. So this file is of size 84 MB, name file 1, and from mount side we still see the only file 1. There are no shards that we can see from the mount side. And if you see the size of the file, it's 84 MB. From the brick side, yes, still the main file is 16 MB, and the GFID is here. So the file F1's GFID is this. So with that I can see the shards created and with the respective indexes. So I see this shards over here, 5 shards. The last one 4 MB, and I'm changing the shard size to 4 MB again. And I'm trying to append the same information, some more information into the same file, say 120 MB. I still see the shard size as 16 MB. It's configured for the file at only once and can't be changed. So if I try to create a different file, since now the shard size is 4 MB, now the new file is created with its own GFID. This is the GFID of it.
So that shard directly is directly next to the file?
Yeah, just it will be in the root of the volume.
Okay.
Yeah, so these are the shards created with it. Yeah, with shards we have sharding provides better utilization of the disks. How it does that is we distribute all the shards into the different bricks. So it uses in a better efficient way. Size of the file is not restricted to the brick. Because now it can be, if the VM image is, suppose say initially when we created it is 2 GB and it grows on to 20 GB, if the one which it got inserted into is only having 10 GB of space in the brick, now with the sharding, since we share all the blocks into different, we distribute the blocks, this problem can be solved. Data blocks are distributed by DHT in a normal way. Which blocks? The shard blocks. Heal at a granularity of shards. Yes. All the files are now sharded. They can be healed like a granular level of a shard. And this is more like I think we don't have time. It's like it's a Manila use case. Suppose we have a volume over here. Which is mounted to some IP. I have not used any SSL schema here. I'm going to tell you it's very simple. So we have a Gluster volume of this, got some IP, say IP, and I'm trying to, previously, if I try to reject some IP on a volume, say, so Gluster volume is not going to take care of it previously. It's lazy unless it gets a remount. It won't see what are the IPs which got rejected, and the customer is going to enjoy the services until we remount it. Okay, I think we don't have a time for this demo. These are guys who helped me in coming here. Raghavendra Talur, he takes care of libgf API, he's my colleague, and most of the sharding work is done by Kritika. That's all. Yeah. Welcome for questions.
So I didn't quite get the part on the sharding. So how does it work? Obviously, in the demo there was only one brick. If I have 3 bricks, would it alternate between bricks, or just write all the shards in the until it fills up?
Yeah, that's a good question actually. I think I missed that point there. So how it's going to, if you have 3 bricks, the shard since the shard feature is sitting on top of the DHT. So all the shards, now the file is say 16 MB, 84 MB file got split into 16 MB. Now if you have to, okay, I'll explain from here so that. Okay, this one. So now you got a file from here, and the shard acts as like the first 16 MB of the file or the block size of yours that you got configured here, that will be as a normal file, and the extra data when it's get appended, that the file will get splitted into the block size that you have configured, and that shard will be given to the DST in a normal way, and that it will distribute to any of the blocks. It can distribute to any of the blocks.
Hashes are applied to the shard names basically, and then
Yes. Right. Any other questions?
What about proliferation of the file system directory when it comes to like huge amounts of shards?
Huge number of shards.
Yeah, like
There's actually each file has a unique GFID. So with that GFID, it's going to store in the root of the volume. So since the GFID is unique, say you have created a volume, even though there are million number of files each has got a unique GFID, and each shard will be appended with an respective index. So you will not have any conflict.
I'm not aiming at conflicts, I'm aiming at performance at the, say, XMS file system level. If you've got really huge numbers of shard files, they live in one directory, don't they? .chart, if I'm not mistaken.
Well, actually, sharding translator itself has some features to address those kind of things. Yeah. Thank you. Yes. Yeah, I'll do it. So here are your
systems that you can give to the people for the questions.